Good morning everyone, my name is Sofia Ramos and today I am presenting our recent work entitled Bioinformatic Analysis of Claudin genes family as therapeutic targets for pancreatic adenocarcinoma. Claudins are a family of 24 transmembrane proteins that form tight junctions. They are involved in paracellular binding and permeability and uses different pathways to control the passage of macromolecules and ions, preventing the passage of microorganisms. They also have a fence rule and the regulation of signaling transduction rule. In pancreatic adenocarcinoma, one of the deadliest types of cancer worldwide, the expression of some claudins is dysregulated, particularly Claudin 4 and Claudin 18, suggesting its roles in tumorigenesis, particularly into proliferation, invasion, and migration. Despite these mechanisms remain unclear, claudins are promising molecular targets for diagnosis and therapy. Since the survival rate of PAD is due to the late diagnosis, our proposal is to evaluate the potential of Claudin family as molecular biomarkers of PAD. To explore the role of each Claudin in PAD, a bioinformatic approach based on TCGA database was used. First, differential expression between tumoral and normal tissues was compared using GP2. In this analysis, the 24 claudins are included. Only the 10 claudins with statistical significant differences between both groups was selected. This set of genes was used to analyze the impact of PAD patient survival using quartiles of expression as cutoff and hazard ratio as risk measure. The next analysis is a correlation between immune infiltrates levels. The Spearman's correlation between the expression of claudins and PAD infiltrates was assessed using Timer 2.0. EPIC and Excel was used as algorithms. Lastly, gene enrichment analysis was performed. Genes positively correlated with each claudin and with a person correlation coefficient higher than 0.3 was selected using Walcon. Gene enrichment analysis was assessed using Chinese Go 0.76.2 using a false discovery rate higher than 0.05. Our results showed statistical significant overexpression of 9 claudins: Claudin 1, 2, 4, 5, 7, 11, 12, 15, and 18. Represented with a pink box compared with healthy tissues with a gray box. The only exception was observed for Claudin 3, which seems which show an underexpression in tumor cells, and for that was included too. The second analysis in heat map represented the hazard ratio based on expression of each claudin in PAD patients and using quartiles of expression as cutoffs. Blue gradient means that lower expression represents a worse prognosis, and pink gradient means that higher expression is worse for patients' prognosis. The analysis of the impact of the expression of each claudin on survival shows that the higher expression of Claudin 1, 4, and 7 have a negative impact on overall survival, and lower expression of Claudin 3, 5, and 15 have a negative impact on overall and disease-free survival. The third analysis presents a set of heat maps that show the impact of expression of each claudin on PAD infiltration levels. Blue gradient represents a negative correlation between claudin and infiltrate, and red gradient a positive correlation. These analyses of a correlation between Claudin's expression and the immune cell infiltration show that the higher expression of Claudin 5, Claudin 11, and Claudin 15 are strongly positively correlated with B cells here on the top, TCD8 cells, macrophage, monocytes, CAFs, and endothelial cells. On the other hand, higher expression of Claudin 4, Claudin 7, and Claudin 18 are associated with stimulation of endothelial cells and lower infiltration of B cells here and TCD8 cells. Claudin 7 and Claudin 11 here are also negatively correlated with macrophages. Lastly, an enrichment analysis using biological processes based on gene ontology was performed. Higher bubbles include more genes, lower FDR or false discovery rate tells us the high probability of enrichment is not by chance, and higher fold enrichment in x-axis indicates the higher percentage of genes in our list belonging to these pathways. Analyzing the enrichment genes positively correlated with Claudins, metabolic processes here and here, for example, adhesion, immune response activation here, and biological regulation, for example, apoptosis here, and development here, are the biological processes more enriched. So, globally, based on the differential expression survival relation with the infiltration levels and biological process related to tumorigenesis, Claudin 4, Claudin 5, and Claudin 7 can be potential targets for inhibitors. Claudin 5, 11, and 15 could contribute to the design of new immunotherapies, but more research is needed to support these bioinformatic results. I want to thank you for Lusófonas University that funded this project.